I thought that exactly why the acoustic speaks. Yeah.
We were. We have to sit where the ventilation is just right in the summer and just right in the winter. Allows for conversation, but not too much.
No, thank you. I want to help you.
So maybe there's one or two more people?
No, I think there's 8 of us, or
Seven.
seven.
Stephanie had to go.
Kevin
Okay.
Burkholder switched to science.
Oh, is that where he is?
I spoke to him at lunchtime.
Oh, there was 16 of them.
All right, I'm gonna pass around the sheet, so make sure you get to sign that. Really?
Yeah, we're supposed to sign that in every class, right?
Yeah, I think so.
We'll have to sign two tomorrow.
There was a box in that first hallway. We got them like kind of after the first class. Do you guys have the registration table?
I'm okay.
They had it. Oh, yeah, I did. Iced tea. Somebody was
Iced tea would be in the car.
It's 27 pages long.
I know.
I'm
Yeah,
not printing it
no,
out.
I
I'll just
didn't
pick it
either.
up when I get here. Did you get yours, Sandra? Everybody else need a packet?
Well, I got mine, thank you.
Does anybody else need packets?
The hiring thing to make it look like we run.
Filled out and turned in.
So what are you teaching us this year?
Area and volume?
Area and volume?
Yeah.
Yay.
Not perfect.
It won't make our head explode.
No, no trig, yeah.
Do you want like a tea or Sprite?
So what? So you guys were just with Mike, right? Yeah. And what was he doing?
We did dance on cinder blocks,
Oh,
and then
interesting.
he gave us a problem that was impossible.
Interesting.
Everyone's in.
You really got
Calm,
panicked
she's
at first.
almost-
Wait for him, like I'm about to say
You didn't make it 5 minutes.
Yeah, we're not good at that.
They're not allowed to be near the video.
No, we're not. Stay away from us.
Which we learned we're just not allowed to be near him and the camera.
Yeah, we don't think they got it. Capture what we were saying.
There's one more person, right? Yeah. And what other quest? So did you have
We had
a quest before that?
Yeah, we had trigonometry.
Okay. So how was that?
It was good.
Okay. So let me start. I'm gonna start off pretty easy, I think, and talk about area and perimeter, at least for a rectangle, and then volume and surface area. At least for a cuboid, kind of simultaneously, so that you can see that there are parallels between the two. So, here's a rectangle. Its distinguishing features being that it has 4 sides and all 90-degree right angles between all the sides, right? So, what does the perimeter measure?
Distance around.
Basically measures the length around. So how do you calculate the perimeter? Just add up the lengths of the sides, right? So this has 2 sides of length x, 2 sides of length y. So that gives us a formula for the perimeter. What does the area measure?
Or time clock.
Yeah, basically the extent of what's inside, right? Let's say amount of room inside. And of course, what's the formula for the area? Extensively. Yeah. One length times the other. Okay.
When you say inside as opposed to surface,
Right, so yeah, let me come back to that. So if I choose some set of units, say like inches or centimeters or feet or miles, what would be the appropriate kind of degree of units for the perimeter? Just inches or centimeters or whatever, right? So so let me just illustrate with this with an example. Suppose that this is my rectangle and that I have units of centimeters for the two sides. Okay, then the perimeter would be what? 12 centimeters. Okay. Okay, now area on the other hand, if I say measure in units of centimeters, would have what? Units, centimeters squared, right? Oops, squared. Okay, so that's one important issue, is to remember that when you deal with area, you have basically two dimensions of length, so you need a squared in your units for measurement. Okay. So let me start here with what I'll call a cuboid. Which has three directions, right, for its dimensions that are not necessarily equal. What would be the volume? X times Y times Z. Notice that one way to think about this is that this X times Y is the area of the base, right? So you could say that this volume is the area of the base times the height of the object. So I'll come back to that idea a little bit later. Now, volume is kind of like area in the sense that the relationship between volume and surface area is similar to the relationship between area and perimeter, right? So surface area measures the outside, and the way you can think of it is, so if I call this, you know, the top, if I cut this, if it were a box and I cut it apart, I can unfold it, right, and lay it out, and it's going to cover some amount of area, right? And that area would be the same as what is the surface area of the box. Do you get what I'm saying? So if I do that, so this is the top, this would be the back, this would be the bottom, this is the front, right? And then here's the two sides. Right? So what are the X, Y's, and Z's corresponding to the sides of each of these pieces? If I unfold, yeah, this,
Oh, yeah, that's two.
right, and this would be Y, right? So what would be this side? And what would be, so these would all be X's, right? And these would be Z's. Of course, that's got to be a Y. What about these two and these two? Right, the bottom's the same as the top, and the front's the same as the back, right? So then how much area does this take up? So I have two rectangles of area X times Y, right? Plus 2YZ 2XZ. So that would give me the surface area for the box or cuboid or whatever. Right? And other shapes kind of work the same way. If you want to figure out what the surface area is, you kind of need to cut it apart, lay it out flat, and see how much area that covers. Sometimes it's easy to figure that out, sometimes it's not so easy. But again, I'll come back to that later on. So let's look at an example. Let's say that that's 2, 5, 3. And let's say that these are in inches. Okay. What would be the volume with the appropriate units? So do 2 times 5 times 3, 30 cubic inches, right? Because now I have 3 dimensions. And what would be the surface area? So I have 2 times 5, right? Plus 2 times 5 times 3. Plus 2 times 3 times 2, right? So that's 20 plus 30 plus 12, so 62. And what would be the unit? Inches squared. So far, so good? Okay. So, let's look at how we can get the area of other simple shapes. So we have obviously a square, which is a special case of a rectangle, right? We have a rectangle. We have a right triangle. So there it goes. Just a triangle. And then a trapezoid. So what I'd like to do is figure out how to compute the areas of these other shapes. And what I'm going to do first is show you that you can figure out formulas for the areas of each of these shapes by only knowing the formula for the area of a square. Right, so here's what I'm going to do. I'm going to show you can get from here to here, from here to here, from here to here, and then using all these combinations, finally the area of a trapezoid. So what is the area of a square? It's still squared, right? Okay. So now suppose that you have a rectangle. And it has sides of length x and sides of length y. How can I use the knowledge about what the area of the square is to determine the formula for the area of the rectangle? That's the problem I want to address. Any ideas? So let me extend this by a length y and extend this by a length x, right? So then what I have now is a big square. What are the lengths of the sides of this square? Yeah, so this all has length x plus y, right? So what's the area of this big square? So the area of the big square is equal to x plus y squared. Which of course is x plus y times itself. And what do you get if you FOIL this out? Okay, so that's one way of computing the area of this big square. What's another way to compute the area of this big square? You can break it apart, right? So this is a square, right? And what is its area? It's y squared. This is a square. And what is its area? And of course, this is the original rectangle. It has some area, right? And what is this thing? Yeah, it's just another copy of this same rectangle, right? So that has area also the same as this. So then another way to compute the area of this big square is to add up the areas of each of the little pieces that make it up, right? So then I can say that this has to be equal to that, right? Does everybody agree? So which of course is x squared plus 2a plus y squared. So then if these two things are equal, what can you conclude?
Area equals x.
Yeah, because the x squareds cancel on both sides, the y squareds cancel on both sides. You get that 2a is 2xy, so then that tells us that the area of a rectangle is x times y, or the one length times the other length, right? Okay. So all I had to know was how to compute the area of a square in order to derive a formula for the area of a rectangle. So now let's go for right triangles. So here's a right triangle. Can you think of a way to use what we already know, that is about either squares or rectangles, to figure out a way to compute? This is half of a rectangle, isn't it? Because I can extend this. Right? So then the area of a triangle is 1/2 times the area of the area of a rectangle that contains it, right, as I've drawn it. And what would be the area of this rectangle? Times b. Got it? Okay. So notice, which two sides did we use?
Ones that make the right angle.
Yeah, the ones that make the right angle.
On this one here, are you saying that A is the same as XY?
I am, yeah. Right, because if you compare these two, what match? Well, x squared is x squared, obviously, y squared is y squared. So then if equality is going to hold, these two quantities have to be the same. So now, what if I have just a generic triangle, not necessarily a right triangle? How can I come up with a formula for its area? I could,
Can you extend out from, like, on the top over and make two triangles on each side?
so I could do this. And then what?
And then extend down. And then you have half.
So what do you get by extending down? I get a right angle, right? So now I have two right triangles. So I don't really need
Oh, you don't need
that because I know now a formula for the area for right triangles, right? However, what's the problem?
Yeah, you don't know
I don't know this and I don't know this. But let's just call that X and call that Y, right? And see what happens. Okay, so here's triangle 1, here's triangle 2, and they're both right triangles. So what's the area of triangle 1? 1/2, right. 1/2 X times H, because these are the two sides that form the right triangle, right? What's the area of T2? Okay. Then the total area, the area of the triangle, is just going to be the sum of the two, right? So what? We can factor out 1/2 H. And what do you know about X plus Y? Yeah, the sum of these two lengths has to sum up to the total length, which is B. So that gives the usual formula for the area of a triangle, right? 1/2 base times height. Does that make sense? Okay.
Can you do it the other way?
I'm sure you can, yeah. You just would have to figure out. So your total thing's going to be whatever the length of this is times B. And then you have to figure out what the length of this is, but it's basically the height. And then this, you have to argue that basically this is half the size of that rectangle. Which it is. Okay, so last but not least, what about the trapezoid? How am I going to use what I already know to derive a formula?
I think you have to draw two vertical lines.
I can draw two.
Like,
Perpendicular lines, right? And now this is made up of a triangle, a rectangle, and another triangle, right? And of course these are right triangles, which makes things even easier. And I have to do the same trick as before. Well, I don't really know what that length is, but I'll call it X. I don't really know what this length is, but I'll call it Y. What's this length? Yeah, it's the same as the top, right? Because I just drew those perpendicular lines straight down. So at least I know what that is. So then notice that X plus D plus Y has to add up to B, right? Everybody see that? Is everybody? So now what do I do in order to figure out the area? if nothing else, I can compute the areas of the two triangles and the rectangle, right? So what is the area of that first triangle on the left? Yeah, so we'll call this the height, right? What's the area of the rectangle? And what's the area of the second triangle on the right? So then the total area should be the sum of the three individuals, right? Now what? I can factor out an h for sure. I have to do one little trick. What's that? X plus d plus y. I can do that. Yeah, so I can replace d. I could replace d with b minus x minus y. So that's one way to do it. But let's see. I don't really. There's a better way. So that's what I would like to do, but I can't. But so this is 1, which is the sum of 2 halves, right? So I could do that. And then I can take out the half. And then I can take one of the d's together with the x's and y's, and that's b, right? But I still have one d left. But anyway, that gives us a formula for the area for a trapezoid. The other idea was good, except for the fact. Sorry, go ahead.
Question. You said b plus d. Oh, that extra d.
Yeah.
Because the x plus y equals d.
Exactly, exactly. The other idea was good, except for the fact that I would have ended up with x's and y's again, which doesn't allow me to go back in terms of the dimensions that were given originally. Does that make sense? So let's just compute some specific examples. By the way, what would you do to compute the area of a triangle or a trapezoid? The perimeter. What would you do to compute the perimeter of, just add up the lengths of all the sides, right? Cool. So this is cool. How do you know, why is this right?
I dropped it on the inside, and then it gave me 2 right triangles.
Well, so
And then it's
yeah,
wrong.
you can cut this up basically and fit it inside of a rectangle, right? Whose length is going to be 8 on one side and 5.7 on the other, right? Another way to think about it is Suppose this was like a stack of books or something. What's going to be the difference between this and if I pushed it together in terms of the area? It would be the same, right? It's just that when you push this together, the height's going to be this much. So the area of this would be the same as if I just pushed it together. Does that make sense?
Dr. Graham, when you say squish it together, you mean so that it forms a vertical?
Yeah,
rectangle?
exactly.
Are you doing 103 later?
Am I what?
They sent us an email about your room change, but it says 103. So in case there's
No one told me.
it'll be closer. That you can
They
get
probably
them.
just, yeah.
I just thought I'd warn you while I saw it.
Okay, so now let's do the area and perimeter for a circle. Except that in the case of a circle, what do you usually call a perimeter? Circumference. And what is the circumference of a circle? The formula. 2 pi. What is the area per squared? So what would be the circumference for the first one? And what would be the area? What would be the circumference? And what would be the area? Is this okay? It's pretty easy. Okay. So let me go back to volumes. So remember we said for a cube that if I know the area of the base, that I can say that the volume is the area of the base. Times the height, right? And this works for any shape if the area of the top and bottom are the same. So suppose that you had just some generic shape like that, right? Where the area of the base and the area of the top are the same. Then I can say the volume inside this thing is again the area of the base times the height. So can you think of a shape besides the cube that would satisfy the same cylinder would be an obvious example. So according to this idea, what would be the volume for a cylinder? I need to figure out the area of the base or the top, either one, which is in this case just a circle, so its area is pi r squared, and then I multiply times the height, so that would give the formula for the volume of a cylinder. Okay. Can I use the idea that we used for the cube to cut it apart and spread it out and lay it down to find the surface area for the cylinder? So if I maybe made a cut like this and then unrolled that, I get a rectangle, right? And then on the top and bottom, I have two circles. What's this? This is the height, right? What's this? Yeah, so it's got to go all the way around the circle, so this has to be the same as the circumference of the circle. So then what would be the surface area of two of these plus that, and I can factor out a 2 pi r. So there's a formula for the surface area of a cylinder. You can do the same kind of trick with these types of shapes as we saw with the kind of the skewed rectangle. If you have a shape that looks like this, right? And then I project down, then I can compute the volume inside here by multiplying this area times this height. So I can compute the volume for like a slanted can or something like that, right? So let's see, what else do I want to do?
So the surface area, you can do that.
So what would be the surface area? That's a little more complicated. So it would be, you would have to know how to figure out this area so you could unroll that. And I think it's going to be the same because you can, basically you're going to get, you know, the slanted parallelogram. So the surface area can be computed in the same way.
Do you use that capital B for the area of the base? Like, that's what we've always used. Like, you didn't use that, so
Right.
that's why I'm just wondering if it's a common thing or not a common thing.
Probably B makes sense. I mean, I would definitely use B. I just didn't think to.
But does the capital doesn't indicate that it's the area of the base?
I don't, as far as I know, that's not like a universally accepted.
Okay, that's what I'm
it's
asking.
probably very common, but
Okay. Thank you.
I don't think anyone would immediately say, oh, that's
Okay.
definitely what that means. Okay, yeah, so here's so just take my word for it that this is a semicircle.
Okay.
Okay. Let's do. So I want to find the areas of these shapes. So what do I do to compute the area of this thing? What's that? Yeah, so I compute the area of this square, right? So that area is 16. And I need the area of the little half circle here. So what's the radius of this? It's 2. But this is only 1/2 of a circle, right? So I do that radius pi times the radius squared. So I get that this would be 2 pi. So I have that the total area would be 16 plus 2 pi, right?
So you have like terms in this, you can't add the 16 and the 2 pi.
I cannot, yeah, I cannot.
But when you multiply the 2 times the pi, then you can add it, right?
I can, what do you mean?
Like if you substituted in 3.14 for pi.
Oh, yeah.
Yeah,
Yeah,
and then
then-
you can add that to the 16.
Right, right,
But that pi makes it an unlike term.
right. Okay, so what about this? I can easily find the area of this triangle, right? So what is it? 15. Okay, and now I need the area of this half circle. So what would be this radius? 5. So you have pi times 5 squared, but that's only half a circle, right? So I get 25 over 2 times pi. So the area would be that, or some decimal version of that, right? The point is if you have like a compound shape, just chop it up into pieces of shapes that you know and compute the areas of the individuals and then add it up.
You have to leave it like that.
Like this? You can write it as a decimal if you want. Is that what you're, yeah.
How is it going to be on the test?
I don't know, yeah. That's a good question. So the same idea works for volumes. If you have a mixture of, if you have an object that's sort of built up from shapes, simpler shapes, you can compute the volume or surface area for that matter of each one and then add the stuff up. So I'll do stuff like that next time, but I'll stop here for today.